Okay, so I'm going to do the solution for Lecture 8, Example 3, which is a single asset, and we're trying to figure out the expected return and the variance. So we're given, we have in this case, we have 4 states of nature. We have boom, normal, slowdown, and a recession, and a probability associated with each. And note that all of these probabilities are going to sum to 1. And then a return, an expected return, in each of these scenarios. So the first part of the question says, what's the expected return on this asset? So what's the expected return on ABC? Well, we know that to calculate expected return, what we need to do is take the weighted sum of the probability weighted sum of all of the returns in each of the states of nature. So what we do is we take 25%, and we multiply that by the return in that outcome, so 0.15. Plus, then we have 50% chance of a boom, and in a boom we're expecting return of 8%, plus 15% chance of a slowdown, and there's a return of 4%, and finally a 10% chance of a recession, and then a loss of 3%. So when I do all that work, I come away with an expected return of 0.0805. So that's 8.05%. So that answers part A. Okay. So remember, this is a single asset. We don't have multiple assets, so we're not in a portfolio setting. It's just a single asset. So the second part of the question wants us to look at the risk element, because remember, this is the reward component of the risk to return relationship, and the second part is asking for the variance, and that's for us the risk element, total risk. Okay, so to do that we want to calculate sigma squared. So sigma squared is equal to the weighted sum of the differences from the mean. Okay, so what we do is I like to set this kind of question up in a columnar format because we have all these probabilities set up. So I'm just going to go ahead and do that. So I'm going to put down all of our probabilities for each state of nature. It's a nice way to organize this question to make sure that you don't make a mistake. And then what I need is the square deviations from the mean. So the mean is 0.0805 in each of the cases. Okay, and then for each of the states of nature, what I need to do is I need to subtract out the observation, and each of these observations are here. So 0.15, 0.08, 0.04, and negative 3%. Okay, and remember I said you need the square deviations from the mean, and then we add all of these up together. Okay, so you don't have to do it in this format, but I find sometimes it can be useful because it organizes the information nicely. So you go through and you do your math, and then you end up with a variance observation of 0.002675. So this is the risk associated with the asset, and more specifically, total risk associated with the asset. Because remember, just a little side note here, total risk can be decomposed into 2 kinds of risks. The first being systematic risk, and the other form being, there's a lot of different names for it, but we could use the terminology idiosyncratic risk. And we've decided that this type of risk can be diversified away by adding assets to your portfolio that have correlation structures less than 1. And so what remains is systematic risk, and we measure systematic risk using our beta coefficient. And this one here is the type of risk we'll be compensated for because we can't get rid of it through diversification. Okay, that was a little side note. So the last piece of the question is looking at part C. So part C says, what is the standard deviation? Standard deviation is simply the, is the square root of the variance observation. So all I need to do is take the square root of the solution in part B, and I'm good to go. So that's 0.051718. So now we have two different expressions, two different ways to express total risk, but they're one and the same. Just this part C, the standard deviation, doesn't have the squared component, so it's easier to interpret this figure rather than the squared version. Okay, because it doesn't have that squared inside of it. Hope that helps.